In this video, we're going to go through Hess's Law. The essential question that we're going to answer is how can we calculate the overall energy change of a chemical reaction using known enthalpy values from multiple steps. Hess's Law states, if a reaction is carried out in a series of steps, the total enthalpy change, or delta H, for the overall reaction is equal to the sum of the enthalpy changes for each individual step. So Hess's Law allows us to calculate energy changes for reactions that are hard to measure directly for a variety of reasons. It also helps us find delta H, or our enthalpy, for a reaction, even if it's not possible to perform the reaction directly. Now, when we use Hess's Law, there are a couple of things that we're going to need to do to manipulate our steps to get them to match up to our given equation. And you'll see what I mean when we get into some examples. But the first rule when using Hess's Law is if you reverse a chemical reaction, you're going to reverse the sign of delta H. So in our example, if it is a negative delta H and I reverse my reaction, it will now become a positive delta H. The other rule that you need to follow is if you multiply a reaction, you're going to multiply each coefficient by that number, and you will also multiply delta H for that equation by that same number. So in our example, I multiplied the reaction by 2, so it becomes 2A, 2B, and I take my 50 kilojoules and I multiply it to become 100 kilojoules in my second reaction. Okay, so here's an example of Hess's Law. It says find delta H for the reaction, and we are given 2 reactions and 2 delta H values. So the first thing that you're going to want to do when you're working a Hess's Law problem is to look at what you have. So, for example, in our given reaction, we have carbon. Carbon is in the first reaction, and it's listed as a reactant. So I don't want to flip the first reaction because there's no other way to get carbon on that side. Let's see, we also have oxygen. Oxygen is present in the first reaction. Oxygen is also present in the second reaction. Okay, finally, we have carbon monoxide. Carbon monoxide is present only in the second reaction, but it's on the incorrect side, so I'm going to need to move it over to my other side. So I'm going to need to flip the second reaction. I need to flip the second reaction to make this happen. So I'm going to flip this, and in doing so, that will change my sign to become positive. Now, if you notice, we didn't go through and look at CO2. CO2 is not in our final equation. We want that to cancel out. So let me rewrite my 2 equations here. So I have copper. I'm going to just leave off the states of matter for simplicity here. And then we have CO2. So that's our first reaction. The second reaction, if we flip it, becomes CO2. And then we have CO plus 1/2 O2. All right, anything that exists on both sides of our reaction is called an intermediate, and we're going to cancel that out. So CO2 is produced in the first reaction, and then it's used up in the second reaction, so it's not going to appear in our final equation. Now, I can get rid of half O2 here, and I can cancel out half of my oxygen in the first reaction. So I'm still left with a half. Now I add up what's left on both sides, so I have carbon plus 1/2 O2. That goes to carbon monoxide. And oh, look at that. It matches up with our original equation. So now it's just a matter of adding up our delta H values. So if I add those up, I get a negative 110.5 kilojoules. So my overall reaction is exothermic because it has a negative delta H value. All right, let's move on to another example. Again, it says find delta H. We're given a reaction. So I'm going to go through and I'm going to circle what I have and where it is. So I have nitrogen monoxide that is present in our second reaction, and it's on the correct side. I have oxygen. Oxygen is in the second reaction, and oh, look at that, it's on the correct side. And then N2O4 is only in the first reaction, but it's on the incorrect side. So I'm going to need to flip the first reaction, and in doing so, it's going to add a negative to that first reaction's enthalpy value. So let's rewrite everything. Flip the first reaction, so it'll become 2NO2 goes to N2O4. My second reaction, I didn't do anything to, I just left it as is, so that'll be 2NO plus O2 goes to 2NO2. Let's cancel out anything that exists on both sides. So my NO2 is present in the first reaction and the second reaction. So we're going to go ahead and cancel that out. And that's it. Now we add them up. And look at that. It matches our first reaction. So now we just need to add up our values, just like we did in the first. So if I add those up, I get a value of negative 171 kilojoules. Just like the first reaction, this will also be exothermic. All right, example 3, starting to get a little more complicated. So again, let's go through and let's find out where everything is. So here we have carbon. Carbon is in the second reaction. It's on the correct side, but we need it to be a 2. So I'm going to need to multiply this by 2. Eventually. Okay. Let's see. We have hydrogen. Hydrogen is present in our third equation. It's on the correct side, so we don't need to do anything with that. And then finally, we have C2H2. That is present in the first reaction and only the first reaction. So we're going to need to flip that to get it to the correct side. All right, so let's rewrite all of this and let's see what we have. Make sure we don't need to do anything else. So we're flipping the first reaction, so that'll be 2CO2 plus H2O. And that's going to go to C2H2 plus 5 halves O2. Our second reaction, we're multiplying everything by 2, so that's going to be 2C plus 2O2 goes to 2CO2. We're going to need to double this as well. So if I double that, it is going to be, let's see, that'll be negative 787. All right, and then the third we left all by itself, so that'll be H2 plus 1/2 O2 goes to H2O. All right, let's cancel out anything that exists on both sides. So water's gone. What else can we cancel out here? All right, so we have 5 halves here. So just for simplicity, let's turn this into halves. So instead of it being 2, this would be 4 halves. 4 halves and 1/2 would be 5 halves. So all of my oxygens will go away. We also have CO2 when we have two of them on both sides. So let's cancel those out. And I believe that's it. Let's add everything up. So we have 2 carbons. We have hydrogen. And then we have C2H2. Oh, look at that. It matches. Now it's just a matter of adding up our enthalpy values. So I plug all these into my calculator. And, oh, I forgot. We flipped this, so we're going to need to flip this sign here. So we add those all up carefully, and we get 226.8 kilojoules. This one is positive, so it will be endothermic. It's going to absorb heat. All right, here's our last example. This one is a doozy. So we've got NH3. NH3 is only in the second equation, and it's the wrong number, so we're going to need to multiply this by 2. We have oxygen. Oxygen is present in the first reaction and the third reaction, but we're going to need it to add up to 5. So I'm going to come back to this after we've looked at the other pieces. We've got nitrogen monoxide. That is present in the first reaction, but it's the wrong number, so we're going to need to multiply this one by 2. And finally, we have, let's pick a different color. Finally, we have H2O. H2O is in the third reaction, but it is the wrong number. We're going to need to multiply this by 3. Okay, now our NH3 is on the wrong side in our second reaction, so we're going to need to flip this as well. Okay, so I said we would revisit our oxygen, so we wanted to add up to 5. So if I double it here, I'll have 2, and if I triple the third one, I'll have 3. So I don't need to do anything else with oxygen. It kind of corrected itself as we went through our other reactions. Okay, so now I'm going to rewrite everything with all of the changes. Since we flipped our second reaction, we'll need to flip the sign. Okay, so let's go through. So for the first reaction, I'm doubling everything, so that'll be 2 nitrogens, and it'll be 2 oxygens, and that'll go to 4 NO. The second one we flipped and doubled, so that will be 4 NH3. And again, we're doubling the other side, so that'll be 2 nitrogens and then 6 hydrogens. For our third equation, we just tripled everything. So we're going to have 6 hydrogens. We're going to have 3 oxygens. And then we're going to have 6 waters. All right, let's see what we can cancel out. So it looks like our nitrogens are going to cancel out. And what else can we cancel out? That looks like it is it. Nope, I lied. We can also cancel out our hydrogens here. Now I think we're good. Let's go ahead and add these up. So when I add them up, we're going to have 4 NH3. We have 3 and 2, so that'll become 5 oxygens. And then on the other side, we're going to have 4 nitrogen monoxides and 6 waters. And look at that. They are equal. So that's Hess's law. It's kind of like a puzzle with a little bit of math involved. All fun, though. Good luck and have fun.